Okay, so we're going to be covering the short version of the lymphatic system, like the most important points, and immunity. And so if I see cell phones, I'm going to assume that you're taking notes, because otherwise that would be super rude to be texting and playing games, right? Yeah, okay. So starting with the lymphatic system, and we clump this into the immune system because it is often associated with the immune system because there are similar functions. And so there's more than just immunity associated with this. Has a very important job. So when we're looking at this picture here, you see all those little green vessels? That represents the lymphatic vessels. So they have their own vessel system, and they're very, very similar to veins and how their structure is. They even have one-way valves, so they return fluid back to the cardiovascular system, kind of the same way venous blood is returned back to the heart by muscular movements and such. You have the same kind of structure and relies on the same type of body movements to return this fluid back. So we'll talk more about what this fluid is and where it comes from. Okay. So lymphatic system. So first of all, we back up talking about the circulatory system. In the capillary beds is where we have those fenestrated capillaries, where the plasma is able to seep out into the tissues, and gas exchange and nutrient exchange, all that great stuff happens. But, so we have fluid that went out into the tissues, but then how do we get the fluid back? So the lymphatic system is designed to collect that fluid that's in your tissues and kind of suck up that fluid into their own lymphatic capillaries. Okay? And so it helps to remove that excess fluid from your tissue. So when that fluid is actually taken up into a capillary, into a lymphatic capillary, then we call it lymph. Okay, so this fluid that we're talking about has several names. So while it is in the blood, it's plasma. While it is bathing the tissues, it's tissue fluid. And then when it is in the lymphatic system, we call it lymph. So make sure you kind of remember what the name is based on its location. And so, yes, the capillaries force that fluid out, and the lymphatic system is involved in collecting and returning that fluid back to the cardiovascular system. But it not only returns it to the cardiovascular system, but it also cleans it and makes sure there's no pathogens, no damaged cells, no junk, trash in the fluid before it's dumped back into the cardiovascular system. Okay? So its major job, I'm going to change the color here. Major job right here, collect and return this fluid back to the cardiovascular system. So we know they have the network of lymphatic vessels that help return it, but along the way, associated with these lymphatic vessels, we have lymph nodes. And I'm sure you guys have heard of lymph nodes before. They get swollen when you're fighting something. Usually most of you, when you have a cold or something, it's right up under your neck, the cervical region. And so there are areas of concentrated lymph nodes. And so notice, so there's a concentration in the cervical region. There is a concentration in the groin and inguinal region. There's also right there within the abdominal cavity. You have in the armpits or the axillary region. And then so then organs, real quick, the thymus is considered an organ and it has an important role in the lymphatic system, as does the spleen. Okay? So those are two organs that are involved with the lymphatic system, and then these lymph nodes are concentrated in particular regions. So you should remember where they're concentrated, so which is mentioned right here. And what happens in those lymph nodes, that is where that fluid, that lymph, is getting cleaned up. Okay? And so when a lymph node is swollen, you're fighting an infection and you're trying to prevent it from spreading. You're trying to keep it localized in this one area so it doesn't spread on to the next lymph node or spread and actually get into the blood, which would be very bad if you had an infection and that got into the bloodstream. You guys know what that's called? Yeah, septicemia, or someone is septic. That's not good. Okay, so a little bit more on those lymphatic capillaries. So there's a little picture here. I don't know if I can make it bigger. I'll try. Ooh, there we go. Okay, so this picture shows you a very simple capillary bed. The red are arteries, then the blues, the veins, and then the green. Lymph, by the way, is not green. Okay, I was just using a different color to illustrate this. And one of the neat things is the ends of these lymphatic capillaries, they're open. So they're like open tubes, which is kind of neat. And so the fluid seeps out from the capillaries, and then these open tubed lymphatic capillaries kind of suck up the extra fluid from those little open-ended lymphatic capillaries. Let me close that, see if it gets back to normal. Okay. Yes, so open tubes, remember that. The fluid just kind of flows right in or gets kind of sucked right in. So anything that's in the tissue space can actually get sucked into the lymphatic capillaries, and because they're open tubes, larger particles can also get sucked in, not just fluid or things dissolved in the fluid. So this is where we get infected cells or pathogens that get sucked in there, which is part of the job, which is again why we clump this with immunity sometimes. Okay, so everything within that space enters the capillaries. So things that we see, first of all, fluid's a big deal. Its main job is to collect that extra fluid, clean the extra fluid, and dump it back into the blood. But you also get other things like debris, dead cells, bacteria, parasites, infected cells, and so we consider this an open system, and an open system means that, yes, you can get these substances in there, but it cleans it really good before it dumps it into the cardiovascular system, and the cardiovascular system is a closed system, okay? So it's very important to have that fluid cleaned up before it goes into the cardiovascular system. Okay. Also, very similar to veins and arteries, the lymphatic vessels also kind of follow the same routes. So a lot of arteries and veins are paired together. We've talked about that. Well, the lymphatic vessels do as well. Good luck trying to identify one of those. They're pretty hard to see when we're doing just our basic dissections because they're thin and they're not dyed, so that also makes it much more difficult for us to see when we're doing our dissections. Okay, so much like the venous system, those small lymphatic vessels come together and get larger and larger and larger until it's eventually dumped back into the cardiovascular system. And where it is dumped is called the lymphatic duct. And this duct, let's see if I can circle it. I see all sorts of great things. Right here is the superior vena cava, by the way. Where is the left lymphatic? Okay, right lymphatic duct is right here at the junction between your right subclavian and your right internal jugular vein. On the other side, you have your left lymphatic duct, also called your thoracic duct, and that's at the junction between your left internal jugular and your left brachiomediastinal trunk. Ooh, that's a fun word. Okay, so the clean fluid is dumped into these two portals. So this is for the right side of your body, and here is for your left. Okay, and then that blood all travels down to your superior vena cava and then into your heart. So that's where it gets returned back into the cardiovascular system. Notice this picture, see if I can make it bigger real quick. This illustrates Okay? So on the right side of the body, and here's our left, the right side, the lymphatic system, only drains half of the head, half of your torso, and then your entire right arm. That's all it works on. Okay? So the right side just has a very kind of a limited amount where it collects the tissue, cleans the tissue, and returns it. So it doesn't do very much. The left side does the majority, collects the tissue for most of the body, cleans it, and then returns it in the left thoracic or left lymphatic duct. So that's kind of an interesting fact I would expect you guys to know. Okay. So, as I've mentioned before, as this fluid... Oh, yes, ma'am.
I was going to ask, remember when we were talking about capillaries or the blood system, the circulatory system?
Mm-hmm.
Some of the blood gets reused or kind of thing when there's a gas exchange in the tissues.
Oh, like in an ischemic?
I'm not exactly sure what it was called, but I was trying to figure out the lymphatic system, where is that located? Is this have to do with the blood?
No. So the lymphatic system does not carry dissolved oxygen or anything. It's just the extra fluid that seeped out in the capillary beds. So we want to collect that fluid so that you don't get all swollen. Make sure it's clean.
Where does that fluid come from?
The fluid comes from the vessels, the capillary beds. So it's essentially the plasma with the things dissolved, and it goes out into the tissue fluids, bathes it with all the, the nutrients and the oxygen, but it doesn't all get taken back into the capillaries because the arteries are putting pressure on the capillaries, so it squeezes out that fluid, but it doesn't suck it back in. So the lymphatic system is there to suck all that extra fluid back, clean it up, and then return it to the blood. Does that answer your question? Okay. Okay, so, yes, as it travels, this lymph fluid is cleaned up because you don't want to put dirty, infected fluid back into the bloodstream, okay? And because it is an open system, that's why it's more likely to have infected cells or debris that you wouldn't normally find in the blood. So we've got to clean it before we put it in the bloodstream. So, yes. Notice right here it says infection could spread from the lymphatic system to the cardiovascular system, then the whole body. So when it gets to the whole body again, what do we call that? Somebody is septic, right? When an infection spreads throughout the whole body. So throughout the lymphatic system, these lymphatic vessels travel through lymph nodes. And this is the key to cleaning up that fluid, okay? And in the lymph node, we have white blood cells. There's a couple kinds that live in the lymph node that live to fight infection, okay? And so because there are white blood cells there, that's one reason it's so closely lumped with immunity. Okay, so looking at the lymph node, it has a really unique structure. So first of all, I'm going to point out a few things here. You have lymphocytes that live in the lymph nodes. That makes sense. They're named for where they're found. This is a type of white blood cell, and they are designed to identify something that's foreign or infected and attack it and neutralize it, okay? And we already know that nodes will swell when we have an infection. So I'm going to zoom in on this picture real quick. Notice we have two types of vessels. We have afferent lymphatic vessels and then one efferent. So afferent is bringing lymph fluid in towards the lymph node, okay? And then fluid that has passed through the lymph node exits via one vessel called the efferent. So this is the exit. Ooh, go away. Okay, and afferent is going in. And the way the lymph node is built is you have this tough capsule that surrounds the lymph node, and this connective tissue capsule kind of actually infiltrates the lymph node and creates all these cavities and crevices, which slows down the flow of lymph through that lymph node. And within those cavities and crevices, you have your white blood cells. So as the tissue is kind of stuck in those little places, it gives those white blood cells time to actually fight the infection. Okay, so body defenses, talking about some specific structures of the lymph node, and we can back up again if we need to real quick, but I did already highlight afferent vessels and efferent vessels. Trabeculae, this is that part of the capsule that extends into the lymph node and gives it those little cavities and crevices, okay? The hilum, this is where, so if I back up, the hilum is this indented portion, kind of makes it look like a bean, and this is where you have blood vessels that enter and you have that one efferent lymph vessel that exits. So this is where you find the blood vessels and that efferent vessel. Oh, and nerves as well. Okay, actually, we already did mention this. So when the fluid is passed through those lymph nodes, it is clean, it's purified, and considered clean enough to dump it back into the blood. And so, again, just a reminder that the right duct does not, or the right portion, only very small amount of your body is cleaned by the right lymphatic duct. The rest of your body is from the left lymphatic duct or thoracic duct, so most of your body is, the lymph is cleaned and purified and dumped in on the left side. Okay. So what happens when the lymph nodes don't work properly? Okay. So if you get blockage of a lymph node, you will have swelling because you cannot collect that extra tissue fluid. And in addition to that swelling that can occur, you can also have other problems like interfering with the immune system and infection. So a very good example of this is elephantiasis. And this disease occurs when you have an accumulation of that tissue fluid, of that lymph. Well, it still is tissue fluid because it's still in the tissue. You have an accumulation of that fluid and it has no way to drain. And so because the arteries have pressure and they're still pushing blood through the capillaries, you're still pushing out fluid from the capillaries into the tissue, but it's not being collected by the lymphatic system. So you get this big swollen body parts. Elephantiasis particularly is caused by a little tiny microscopic worm called a nematode. So it's nice and tiny, and what this does is, especially if you're barefoot and you're in a tropical location, if you have a little wound on your foot, these guys live in the dirt, okay? It can enter through the smallest little wound, and it travels in your tissue, and it really likes to live in your lymph vessels. So it goes in the lymph vessels, and it's getting all this great nutrients and stuff from you, and it starts to fatten up until it eventually blocks. It gets stuck in a lymphatic vessel, and it's blocked. It doesn't care because it's still getting nutrients from that fluid, but it's blocked. And now that it's blocked a vessel, a lymphatic vessel, all that tissue fluid continues to accumulate. It has nowhere to drain. And it just gets swelling, just gets worse and worse and worse until you actually have permanent damage to the tissues. So notice, these worms live in the dirt in tropical climates. This is where people are going to get it. So you're probably safe here in Nebraska, but if you go travel anywhere that it's much more warm and tropical, wear sandals at least, okay? Here's some more illustrations of elephantiasis. This is an old picture this is in the 1800s, of a woman, covering her face because she needs to be modest, but she has it in both legs. You can see the rest of her body's normal, just those legs. Or in this person here, only one leg is affected. And it's called elephantiasis because of what it does to the skin. It makes it look a lot like an elephant's skin. This person here, nice normal hand, and then she has 3 fingers that are affected. Notice here's the other 2, totally normal. She was probably gardening, if you think about it. This was They have a lot of missionaries in tropical areas, including Amish and Mennonites. I've met some of them. It's really kind of cool, actually. So she looks like one of those people who's missionaries. This guy, I believe, is in India, but he has it on his face. So I don't know if he got his face smashed in the dirt, but so he has that growth on his face, which is a really unfortunate place for that to be. So people who travel and come back, we would notice pretty quickly if we had swelling. We'd go to the doctor, you'd get medication, you'd kill the worm, and you'd be fine. This happens in places where there is not good medical care.
So if it gets like that out of hand, like mental health?
Nope. You can kill the worm. Surgery could get rid of some of that extra tissue, but there's also a lot of extra vessels to feed the tissue, so it's tricky. Some people actually will get amputation just because it's easier than hauling that around. To be honest, amputation is one way that they have treated it in the past. Okay, thymus gland. We have talked about the thymus before and how it's involved in immunity and how it's largest in children, and as we age it shrinks over time. Remember that? So we want to remember this. It sits right on top of our heart. And so what does the thymus actually do? Why is it important? Well, it secretes hormones. We didn't talk about these hormones in the hormone chapter. That's okay. And what they do is that this stimulates stem cell division. So we just talked about stem cells the other day when we talked about blood, and that involves white blood cells as well. But then, here's an interesting thing. There's two types of white blood cells, T cells and lymphocytes. When they're immature, they travel to the thymus, they mature in the thymus, and then they go do their job, which is, it's kind of cool. So back up again. So maturing in the thymus, so the lymphocytes develop and mature there, and the T cells differentiate into two different types of T cells. Just know that these two are affected by the thymus, okay? The spleen is another lymphatic organ. Again, it is very closely related to the cardiovascular system, which is why we try to kind of put them all together when we cover these topics. So, 3 functions of the spleen that you should know. First, it does help getting rid of abnormal blood cells, so it could be those blood cells that are old. Remember, blood cells live about 120 days, red blood cells. Okay, so when they get old, they can be filtered out and taken care of in the spleen by phagocytosis. Also, some of the iron is stored in the spleen from recycled blood. Okay, and the third thing is that it also has a very important role in the immune response. So it's where the immune response is triggered or begins, because you have B cells and T cells, which we'll talk about in a little bit, that live in the spleen. Okay, and so they are going to be one of the first ones that are going to be triggered for an immune response. And notice really quickly, the spleen has very similar functions to the lymph node. Notice how we have this capsule that surrounds it, and then it kind of comes inwards, a tubercule, just like we saw with the lymph node. And then there's a very big, good blood supply, which is one of the reasons why if someone, let's say, damaged their spleen, you have to be really careful because you don't want them to have internal bleeding. That's the big deal with the spleen. You can live without your spleen. You'll be okay. Other parts of the body will take care of most of this, most of the functions, but the spleen is sometimes removed when it's damaged and it's bleeding. So that's the problem with the spleen. Okay, lymphocytes. Different types of white blood cells, or lymphocytes specifically, that you'll find. So 3 classes of lymphocytes. You have T cells. T cells are dependent on the thymus, so that helps. T for thymus, okay? Natural killer cells, we like those. Those are our 007 cells. And then B cells come from the bone marrow. So B for bone, okay? T for thymus. That should help you kind of remember where they develop, where they're developing. Okay, so back up again. So there's 3 categories: T cells, natural killer cells, and B cells. So now we're going to talk about T cells, different types of T cells that you have. There are 4 types. We have cytotoxic T cells, helper T cells, suppressor T cells, and regulatory T cells. We're just knowing the basics about these. So the cytotoxic, cyto means cell, so toxic to cells. So these T cells attack other cells that are affected by viruses. Okay? They're involved with what we would call cell-mediated immunity. And so we're going to come up with very shortly talking about these types of immunity. So these T cells attack virus-infected cells. Helper T cells, they help, simply put. So they stimulate T cells and B cells to get functional. Okay, so it's kind of like they help wake them up. Suppressor T cells is going to inhibit the function of T and B cells. So helper T cells stimulate them to their function. Suppressor T cells inhibit their function. Then you have regulatory T cells, and they're both helper and suppressor cells. And so what they do, what does regulatory do? Here's the important part. Controls how sensitive your immune response is. It's from exactly no response at all the way to an anaphylactic response. So regulatory just determines how strong of an immune response you have. Okay? So a little bit more on T cells and B cells. Remember, these are white blood cells with specific names. So both of these, they're throughout the body, they're wandering throughout the tissue, okay? What's unique about them, remember these are white blood cells, they can actually divide out in the tissues. So they can replicate and make more white blood cells. So it doesn't all have to happen in the bone marrow. And so because they have the ability to divide, it's really helpful and important in the immune system. Okay, antigens. We haven't really talked about antigens. This is something you would see on the outside of a pathogen, or let's say a bacteria, for example, that your body recognizes as foreign. It doesn't belong. So an antigen doesn't belong. So your body recognizes an antigen as a foreign substance. Okay, so foreign and pathogen. And then we have our antibodies. Remember, antibodies are immunoglobulins. And so a specific antibody will bind to a specific antigen. So it's like the receptor thing again, where it has to be the perfect fit. So an antibody only works for a very specific type of disease, for example. We've all gotten vaccinations for different types of diseases. That builds up our body's immune response. We build up antibodies for it. And if we have that antigen from, let's say, I have to go get the typhoid fever vaccine very soon. If, let's say, in a month and a half, I'm exposed to typhoid fever, well, my body already has antibodies for it. So my body can launch an immune response very quickly without me feeling sick. And that's kind of the whole idea. So the immunoglobulins, the antibodies bind to that specific antigen that doesn't belong and then starts the immune response of killing those cells that don't belong. So there are 2 main categories of defense: immune system defense against something that does not belong, or a damaged cell or a mutated cell. Okay? So there's 2 categories. Definitely need to know your 2 categories. You have non-specific defenses and then specific defenses. So we'll talk about each of those briefly in a moment. So ideally, the non-specific and the specific defenses should work together to help protect your body from infection and disease. So first, shortly, non-specific defenses, they will always work the same way, okay? And they'll work against anything that's foreign. And the next slide is a list of non-specific defenses, okay? Specific defenses, this is where you use your antibodies that are specific for a particular disease, okay? So a specific pathogen. So most of you have had vaccines for chickenpox. So you have those antibodies, the memory of those antibodies. So if you come in contact with it, your body just makes the antibodies really quickly, fights it off, and you don't ever feel sick. That's a great thing. But instead of chickenpox, let's say you got the flu and you didn't get the flu shot. Well, then you're going to get sick because remember, the antibodies are specific to a particular disease. You only develop specific defense after you've been in contact with a disease or you've gotten a vaccination that causes your body to make those immunoglobulins. Okay, so here's a list of non-specific defenses. So first one is physical barrier. The largest organ in your body is also called the first line of defense. Anybody? Your skin, yeah. If your skin is unbroken, it's basically this wonderful barrier that prevents infectious diseases and pathogens from entering your body. That's why we call it the first line of defense. I'm going to put that there. Okay, then we have phagocytes like monocytes and macrophages that engulf things that are infected or old or don't belong and break them down. Then you have immunological surveillance. Those are by the natural killer cells, by the way, because I love them. So those are the ones that wander around just looking, making sure there's no trouble. If they see something that doesn't belong, bam, they're dead. Okay. Interferons, these are chemicals that are released as kind of a SOS call for more help. So these chemicals are released, just asking for more white blood cells to come and help fight the battle. Okay. Oh, go away. Stop it. What's the deal? Sorry, guys. What happened? Sorry, something happened. Trying to fix this. Anybody? What did I do? Shoot. Okay, chemicals. Complement. This is where you're using your antibodies. Okay. Inflammatory response. So if you get a cut, it might get infected. It's red. It's hot. There's a purpose to that. It brings in more blood supply, kind of helps block the spread of the pathogen. It increases the temperature there, which actually helps the white blood cells work even better. And it calls in more help, more white blood cells to help fight the battle. Okay? And then fever, I don't want that. Okay. Fever is also, remember, non-specific, but you, in response to being sick, raise your body temperature, and that makes it harder for viruses or bacteria for those cells to divide. It helps your white blood cells to be more active to help fight the infection. So it has multiple important purposes to it. I don't know what the deal is with this pen, but something is wrong. Won't let me change this. Guys. Oh no. No, you didn't. Does anybody have one of these? It won't let me change the picture. worries. I would like to keep going. What did it do? Give me 1 second. I'm sorry. Okay. Oh, good. It works again. Whew. I don't know what I did. Okay. Specific defenses. So this is where we use our antibodies against the antigens, those foreign things that are on cells that don't belong or are infected by viruses. Okay, so our specific resistance, that is our immunity. So I think most of you guys, if you're living in the dorms, you had to get like your hepatitis B shots. Is that right? You guys have your hepatitis B? You should. You should. You should have had to before you came here, because group conditions spreads. Okay, so for example, so I've traveled, so I have the hepatitis B vaccine, I had the hepatitis A, I have typhoid, some fun things, and that gives me specific immunity to those specific diseases. So if I'm exposed to food that was not handled properly in a third world country, I'm not going to get hepatitis B because I have the antibodies for it. Thank goodness. Okay, so that gives me specific defenses against a specific disease. So that's the whole idea of the specificity. Okay, and this relies on your T cells and your B cells. So remembering, T cells depend on the thymus. Yes. And B cells are made and differentiate in the bone marrow. Oops, bone. Okay, so T cells are responsible for what we call cell-mediated immunity. So we'll talk more about that in a moment. And T cells help against abnormal cells and pathogens inside the cells. So an example of an abnormal cell could be a tumor cell. Okay? B cells are involved with antibody-mediated immunity, so you're using antibodies in this case, and this defends against cells that have foreign antigens or pathogens that you find in the fluids. Okay, so if we notice here, this is inside the cells, the pathogens inside the cells, and B cells are more in the body fluids themselves. Okay, we're going to make it. So this is a really great breakdown of specific defenses and the different types of immunity you can acquire. I would like you to spend some time with this. Okay, so I will very briefly kind of walk you through it, but you will need to spend some more time on it. And notice it's starting, we're only talking about specific immunity. Okay, and there are two main categories for specific immunity. One is innate, and the other is acquired. So innate is something that you're born with, genetically predisposition to be able to fight something without ever being exposed to it. Okay, never exposed to the disease, but you're able to still have immunity for it. Then secondly is acquired immunity, and most types of immunity are acquired. Okay, this means you got immunity from getting sick, someone gave you the antibodies, or you got a vaccination, so you've acquired this immunity in some way. So acquired immunity breaks down into two categories, active and passive. So you got to know those. Active immunity says produced by antibodies that are developed in a response to an antigen. So your body's actually launching an immune response, whether or not you actually got sick. So naturally acquired active immunity is where you actually got sick, fought it, your body has made antibodies, and you won't get sick again in the future. So like me back in the day when they didn't have vaccines for chickenpox, we would get sick, And then we would no longer be able to get sick again because our bodies developed an immunity for it. In fact, they actually, like, if a kid got sick with chicken pox, they'd have like a party at his house, so we'd all get it, so then we wouldn't get it again later. I'm not kidding. We just wanted to get it out of the way, get the kids sick, get it out of the way, then they won't get sick in the future. I'm not kidding. That's the 80s for you. Okay, and then the other type of active immunity is induced active immunity, and that would be when you are given a vaccination. Okay? Down here at passive, this is where you are receiving an antibody from another person. So one naturally occurring is with a baby and its mother. You can get antibodies through the placenta and especially through the breast milk. So it's not actually getting, the baby is not getting sick, but it's getting the antibodies from its mother, from the breast milk, especially the colostrum. The first few days of breast milk is especially rich in those antibodies, which is why it's so important that if a woman can breastfeed, she does it, because it's so helpful in her infant's immunity. And then the passive form of this is where you are actually given a shot of antibodies to a specific type of disease. And they do that with allergies, for example. People get immunoglobulin shots against certain types of allergens. Okay, so B cells are responsible for that antibody-mediated immunity, so we're using the antibodies. And the antibodies, again, each one is specific, just like a receptor can be specific to a particular molecule. And there you have this Y-shaped structure here. Let's see if I can scoot it over. No, it won't let me scoot it over. So you have a heavy chain and a light chain. And the ends, the part that stays the same is this bottom portion. So the end parts of the antibody is what you'd consider the variable portion, the part that changes and can conform to the particular antigen on an infected cell. And so, let's see. Here, just making sure I'm not missing something on this slide. No. Okay. This is a picture from probably not your textbook, I don't think. But it shows you there's 5 classes of antibodies. So you have IgG, IgE, IgD, and IgM, and IgA. Okay? Let me see. What do I want you to know? Notice this. IgE is responsible for more of the allergic response because it's activating basophils and mast cells. Okay, so allergy and inflammation. Okay, so read through these so that you are familiar with those. Okay, you have primary and secondary responses. We still have 5 minutes. You have a first exposure and a second exposure. So if you've never been sick before with, let's say, chickenpox, and you didn't take the vaccine, the first exposure, you're going to get sick, okay? And it's going to take a while for your body to develop those antibodies so that you can actually fight off that disease. So you'll get sick because it takes time. But if you are exposed to it in the future, you're going to have a secondary response, which you're going to have your memory cells. These are a type of cell that makes your antibodies. They're going to recognize that antigen, and they're going to pump out a bunch of those antibodies for it to fight that infection without you, ideally, getting sick at all. Okay, we have a couple slides on disorders, and we have time, so stop acting all antsy, okay? So immune disorders, very important aspect of the immune system. So autoimmune means it's affecting yourself. So there's something wrong with your own immune system. And what happens is that your immune system attacks your own tissues in your body. And it can cause some serious problems. So basically it ignores what your body says is normal and attacks those normal cells anyways. So some examples of autoimmune diseases: thyroiditis. Your immune system attacks your own thyroid gland. That's no good. Rheumatoid arthritis affects the synovial joints, and usually it's bilateral, so if it affects the right hand, it will also affect the left. And then also there's a form of diabetes that is also autoimmune. Some more immune disorders. There is one called SCID, is the abbreviation, so severe combined immunodeficiency disease. This is when in development the fetus is unable to develop the correct lymphoid tissue. And so this is kind of the example of the bubble boy, where you have to kind of sequester someone so they don't get exposed to any of those diseases because they cannot fight them. Viral infection, HIV. What this does is it affects white blood cells, and it prevents the white blood cell from putting out anything that says that it's sick or infected. So your body doesn't know that it's infected and can't attack it. And it just goes on and kills white blood cells and uses them to make more viruses. And so one of the characteristics of HIV is over time it's killing all these white blood cells until your white blood cell count is so low that you can't fight simple infections. Simple infections like a yeast infection. And there's a whole bunch of other ones. And so people, when their immune system is so suppressed and they have hardly any white blood cells, and they're getting these opportunistic infections, then you've moved to the stage that we call AIDS, the acquired immune deficiency syndrome. Then lastly, we also have immunosuppressant drugs that are used to, for example, prevent, what's the word I'm looking for? Rejection of transplants. Radiation, for example, too. So these immunosuppressant drugs can suppress your immune system for a good reason, but if it's too much, your immune system's going to crash. Hold on, I have like one slide. Oh. Okay, I want you to read. This will not be hard. Okay, allergies versus allergen. Easy peasy, okay? Know what anaphylaxis is, okay? Let's see. This one, I was talking about chronic stress. Remember we were talking about final exams and how when you're under stress, it lowers your immune system? Maybe, maybe not. This is talking more about that. And this is the last step. So I may ask you an effect of aging. So there's 4 things listed there. We're done. All done. So